Thanks for joining me again. We ended off with question 20. This is the fourth part of our series where I teach you how to tackle SAT math problems. In question 20, we're asked the expression right here, notice that we have radicals here, specifically square roots, is equivalent to. Now you'll need to know how to reduce radicals. That's part of algebra. And in case you forgot, here's what you do. First of all, the factor at the top, we have the square root of 32. There is no perfect square root of 32, so we can actually break down 32 into its factors. What numbers multiply into 32? 16 and 2. So you can break 32 down into 16 times 2. The reason why this is important is because now this 16 is actually a perfect square. And when you have factors, you can give this radical symbol to both of the factors. So I can give it to 16 and also give it to the 2. The square root of 16 is 4. 4 times the square root of 2. That's what I've reduced that down to. So I have x times 4 times the square root of 2. That's the top part. In the bottom part, we have the square root of 4x, again using the same property as before. Essentially, it's the exponent laws that we're using here. We have the square root of 4 times the square root of x. That becomes 2 square root of x. Okay, the 4 and the 2 can cancel out. That becomes a 2, leaving us with 2x times the square root of 2, and at the bottom, the square root of x. Let's see if that's one of the options. So we see it right here, and that happens to be the answer. Sometimes they may ask you to rationalize the denominator. In other words, you are not allowed to have a square root at the bottom. So if I multiply the top and the bottom by the square root of x, what happens is when you multiply these two together, the radical symbol disappears at the bottom. So we end up with x at the bottom, and at the top we have 2x. That stays the same, that stays the same. And these two can be multiplied together because they both have the square root. So we can write down the square root of 2x. Is that one of the options? It's not. Good. So E is the answer. In question 21, what is the next number in the series? I hate these types of questions, I'm not going to lie. So we have 3, 16, 6, 12, 12, and 8. They require a little more thinking, so I'm going to skip it, but I'll return back at the end of this video. In question 22, the volume of a glass of water placed in the sun decreased by 20%. So I'm going to say that the volume is decreases by 20%. So there's still 80% left. If there is 24 milliliters of glass, now, what was the original volume of water? All right, we have to adjust this a little bit. Actually, no, we just multiply 0.8 by 240. 0.8 by 240, that was the original amount, so no, that's the new amount actually. Okay, so if that's new amount, then I'll put it here, 240, that's V new and V old. To find out V old, I divide both sides by 0.8. So 240 divided by 0.8 gives us 300. Luckily, that's one of the options. Next one. What is the 10th term of the pattern below? Okay, this falls into the same category for me as question 21. So I'm going to skip it and return back to it later on because it does require more thinking. In question 24, how does the area of a rectangle change in both the base and the height of the original rectangle? Let me reread that. How does the area of a rectangle change? The area of a rectangle is A is equal to length times width. If both the base and the height, so they're using B and H instead, right? B times H. So forget that. If both the base and the height of the original rectangle are tripled, so this is being tripled, and tripling something means that we multiply that by 3 and that by 3. Both of them are being tripled. Okay, if that's the case, we have 3 times 3 is 9, BH. So the area is 9 times, from what I see, the original. I'm going to choose C. And finally, on to our last question before we revisit those that we skipped. The equation y is equal to this is undefined when x is equal to. For this, you have to find the domain. And the domain specifically one of the restrictions with fractions is the bottom, it can't be equal to 0. So x squared plus 7x minus 18 cannot equal to 0. We have to find out when it is, and from there we can figure this out. This is factorable. There is a 1 at the front, so what two numbers multiply to negative 18 and add to positive 7? It's negative or positive 9 and negative 2. So I'll break this down into factors, positive 9 and negative 2. And let's solve for x. We have x is equal to negative 9 and x is equal to positive 2. Are any of those an option? Yes. We have negative 9 right here and no positive 2. So A is the answer. All right, let's revisit this one. What is the next number in the series below? 3, 16, 6, 12, 12, and 8. Okay, let's see if we can find a pattern. 3 times 4 is 12 plus 4. That doesn't work for the next. So this goes up to 16, and then this drops and then goes up, stays the same, and so whatnot. If I raise 3 to the power of 2, I get 9. That doesn't work. Raise 3 to the power of 3 is 27. So 3 to the power of 3 is 27. Subtract 11. All right, let's see if that works here. No way. It doesn't. 16 to the power of 3 is really big. There's got to be a better way to think about this. All right, notice this 3 and this 6, they're doubled. And this 6 and this 12 are doubled. And from here to here, they're being subtracted, and from here to here, they're being subtracted. I got lucky here. That's what it will be. Hence, if this is being doubled, that's being doubled, then this should be doubled, it should be 24. I got lucky. Let's try this one. What is the 10th term of the pattern below? Okay, this is being squared, squared, squared. So, no, I take that back. 3 to the power of 2 gives us 9. Okay? 3 to the power of 3 gives us 27. 3 to the power of 4 gives us 81. 3 to the power of 5, well, I don't know. 3 times, or 3 to the power of 5 is 243. 243. So we should end up, oh my gosh, the 10th term. So that's the first, second, third, fourth. That's the 4th term. That's the 5th term. We have 3 to the power of 10. The only one that does that is this one. You see, we have 2 raised to the power of 10, 3 to the power of 10. Nothing else has this pattern. Well, actually this one does, but it can't be 2. The 2 does change. So E is my answer. And there you have it. That concludes part 4 of our SAT Mathematics Prep. We will have more parts to come, so make sure that you watch them for preparation on your upcoming SAT test. We'll see you soon.